Hey folks, welcome back to another video. This will be the follow-up video I kind of mentioned in a community post when I said I wasn't going to put up video 2 on the Sidecar Leading Link project because of poor performance on video 1, and I want to kind of explain that real quick. That reason still does stand, but this ended up being an extremely complex job, complicated job. It would have been almost impossible to film. I have a ton of clips on this, and we're going to do something with them here toward the end of this video. I promise I'll show you something. But I have a ton of clips, and the editing probably would have taken me 8 hours to do, and the video would have been 3 hours long, and if I was going to get only 400 or 500 or 600 views, then it's just not worth it. You know, no offense, it's not your fault, it's my fault because of the content, all right? But if I'm not going to get the kind of views for that kind of work, I just can't justify it. That's really going to be the new model as far as videos go, unless it's something really extremely exciting or interesting as far as like a rare bike or something weird, you know, something different. If I do a video 1 and it's going to spill over to another couple of videos, depends on how video 1 does. If I have good response from video 1, I'll do video 2 and 3 and so forth. But I just can't justify the time and I can't justify the effort if the content is just not good enough to generate any subsequent or any follow-up videos. So just the way it's going to be. As far as this goes though, this job is done. I'll show you that in just a second. I just wanted to tell you that this thing really drives great. It gives me good feedback. It steers great. It steers straight, now with a little tweaking, but I'm overall very happy with its performance. So that was just a couple of quick clips from my ancient GoPro of this thing in action. Hopefully they come out okay, because I actually haven't shot them yet. I'm doing this prematurely. That always seems to happen with me. Anyway, that's another matter. So let's take a look at this. And then I think what we're going to do is, right after I finish walking around with this, not going to take long to show you the different features of it. I'm working on it right now. I'm doing a compilation or a summary video of all the machining involved in this that I actually recorded. I didn't record some of it, because when it got too complicated, I'm like, I'm done with recording all this. I just really had to concentrate. But I did have to do a lot of machining on this, and again, I will kind of put it right after we get done with this walkthrough. It'll be right after that, and then no outro as far as me yapping at you. You'll just see that, and then the video will end. So let's go downstairs here onto the floor, and we'll take a look at what it looks like now. I got to do an upside down reverse doobly-doo with you here, but you can see right now, this is the right side. Now you remember that part on the right lower side, that was that part that I really didn't like that helps capture the axle in place. Well, you can see that I redid that. And I didn't ultimately want to do one of those, but I was kind of forced to do it. Well, not exactly forced to do it, but that little block looking thing with the 2 cap bolts in it, that retains the axle as far as in relation to the arm. So in other words, the arm can't move inboard, because the axle is fixed through the axle itself and the spacer on the inside there. You can see the spacer. And as far as that spacer goes, that is set to a certain length, and I cut the axle back, because you saw me make the axle in video 1. And so that is cut back. So essentially about halfway through that square tubing is where the shoulder of the axle and the spacer meet. And so then, of course, that's all tightened up across to the other side, and so that's all pulled together. But what I didn't want to have happen is I didn't want to have any chance, even with the way this thing is cinched down, and we'll go into that here in a second, of essentially the tube moving inboard away from the inside head of that axle bolt. So I came up with this. This is just an old piece of steel from something that actually came with my old lathe. It was like an old homemade tool holder. And I milled it down, drilled a couple of M6 holes. That's double walled in there, inside that, because that was originally double walled from the original configuration. A lot of threads, holds it in place, everything's good. Now you'd think that that looks like silver paint, but it's not. We're going to get into that here in a second. Regarding this spacer deal and this feature on the outside here, I could have eliminated it altogether by putting a shoulder on the inside of the spacer. You see the spacer inside there. If I shouldered the inside of it where it hits this tube, the square tubing, you have the head of the axle out here, really a big long bolt. You wouldn't need this because of a shoulder on the inside, it would be sandwiching in between like this, right? Well, I did try that, and I thought I was very clever with doing it. The trouble is, you can't get the wheel back off. When I was doing it, the right or the left spring was not actually, neither of the springs were on. And so you could swing the left arm out of the way, down or up, independent because the axle's out. Then you can get the gearbox for the speedo out, which is the other side. That's really the spacer for the left side. So the trouble with this is, with the shoulder, because this needs to come inboard inside the tube once the axle's out to make room to disengage the gearbox, which again is a spacer. You can't get the wheel out unless you take the shock off. And I said, that's a no bueno. So I ditched that idea and just machined that edge down, that shoulder I had made on this. And again, they meet about halfway in between here. Almost dead nut square, halfway in the inside of this. And they clamp equally down. That way there's not anything like right toward the edge on either side. Because remember, the inside is a larger hole than the outside. So that's the reason why I did it that way. And I did try what I thought would be a clever idea, but it just didn't work out. One of the biggest problems I had with this was I could not get things to line up exactly right. And what I mean by that is I could not get things to line up as far as the axle going through and going into the threads on the other side and having the thing where it actually went through and didn't bind up. In other words, the axle seemed to be a little cockeyed in this hole where it wanted to go through. So what I ended up having to do was, I ended up having to take this right side arm and I cut it in half. And then I used a piece of 1.5 inches and put it inside there and then double walled that as well, plug welded it, and then welded it up because the space, this extended out basically this way, was about 10 mil, maybe 12. And so I put a filler piece inside of it, just a piece of 1.75 inches, which is what that is you're looking at, and then welded it all up, yada yada. So that solved that problem mostly, but I still had some alignment issues, but I did correct those. Now this part you can see is the replacement part for that piece that I cut off for the right brake. That came out perfect. The brakes don't drag anymore. They don't make any noise because I clamped them down like I said I was going to do in video 1 to get that aligned, and it works great. Let's go back to this part, which is the hinge points. Now you can see that these are different than what I said I was going to do. And there'll be some machining video coming up here on how I made these. Those diameters are up to 700 thou now. They were a 1/2 inch before. Well, actually 5/8 because there was a 5/8 spacer, 1/2 inch to 5/8. We're going to show you some machining of that as well. But I did line bore those through on, well, sort of line bore, straight bore them through on the mill with the boring head. We'll go over the other side. It's easier to see this one. And you might notice that the spacers are offset, and I had to do that. So all the spacers are on one side. And the reason why was because I needed to get the front tire aligned with the rear tire. Not really sure why it didn't want to line up. It may not have on the old version, I don't know. But so all the spacers are on the right side. It kicks this tire over our way, you know, toward me, and makes it so it lines up better. And you can kind of tell that, because I had it out before, about the road marks, because these are brand new tires on both front and rear. It's another thing I did. Pretty even. So that worked out pretty well. So again, I'll have some machining of these guys in there. And this came out really well, but instead of putting the grease nipple on the inside, I put it on the outside. So that's a lot easier to get at. And as far as the gray color, I mentioned it on the other side. This is all zinc plating. I figured out how to do zinc plating in-house, and I'll have a couple of clips on that coming up too, where I do some zinc plating in-house. I cannot believe how good it came out as far as that process. That is actually really easy. I'll put a link in the description to a website for a Corvette forum that I found that somebody had the mixture of how to put that together as far as vinegar and yada yada to make it work. It worked great. So these braces, which were previously painted black, these are zinc plated now. So that came out really well. I didn't have to wait for paint to dry. The front axle's all zinc plated as well. Anything bare metal that I made, essentially, anything, got zinc plated. Spacers, these pins, the axle, anything I made. I also made these guys here. They're gonna be really hard to see, but up inside there is mounts for the rooster fairing. You see them right there? I made new ones of those while the thing was off, because the ones that I were using were just really horrible. Yeah, this is what we were using before. I got it back on the back of the Connie where the GV box goes. That's what I had in there before. It's not metric because it doesn't go into anything metric. It goes into a bracket that I made years ago because I had to push the headlight out forward. That's what holds that in, and these things are just horrible. So that's why I wanted to remake those, because I had it off, I might as well do it. So those got zinc plated as well. I mentioned in video 1 about the length of the down tubes, how the down tubes essentially stuck up. They were stuck up, damn it. They stuck up in the air, different heights. And what I mean by that, you see that cap down in there? See if I can get it this way. Yeah. That cap behind that, you know, right where you can see the fork tube protruding, is about the same as this one now, which it was not the case before. I had to bring one up and one down to get things lined up, and I never liked that. What I achieved by getting those balanced, if you will, is pushing the entire thing downward in the tube, and that's a 30-degree angle. And unfortunately, the only trigonometry I know is something to do with trigonosis. I can't figure it out. If you calculate that out somehow, it's pushed it out maybe 1/8 of an inch, so we have a little bit more reduction of trail is what I'm getting at by just pushing it down. It may be only a 1/16, it might be 1/8 of an inch. That makes a tremendous amount of difference though, you'd be surprised. And I think that's one of the reasons why this thing handles so much better. You can also see I capped off the end of the tube. Both of the front tubes were open. They were not closed tubes. I don't know why I had it that way, but I just never finished it, basically. With this done the way it is now, this thing looks a lot neater. And over here, you know, because this one's got to be able to pinch down the axle, I couldn't put a welded plate on. So that's just a sheet metal cap that I made. Now you remember the other one, the original configuration had 2, I think they were like 3/8 24 bolts going through, and I told you I was going to change it to 1, in which I did. I welded them up and I put it on the mill, and I used the edge finder and went right in the center of it. That's a 12 mil, I think it's a really hard metric bolt, cap bolt, and then a nut on the top there. And what I also did was, which was not in the original configuration, see if I can show you. If you look really carefully, you can see that little cut vertically above the nut. I used a 1/8 end mill, and I went in there and I cut that slot as a relief. So essentially this, you know, this will pinch now, which is pretty cool. So it pinches a lot easier, and it's not gonna break because that's a round end. So I was thinking about using a saw, but the saw would tend to wanna crack at the end of that slot. So using a round end mill was the way to go. Let's go back to these rear ones here. The tabs on the lowers here were not lining up vertically with the uppers. They were kind of cocked at an angle. What I ended up doing was I ended up putting them on the mill, and I side milled them. I side milled the top, side milled these, so they'd be more square. They were a little bit bent before I started. What I should have done was I should have straightened them a little bit and then mill them, but I just didn't think of it. And so I ended up side milling those, but there's plenty of meat because I overbuilt this thing originally anyway. And so now those are essentially parallel. I wanted to not have a situation where the thing was like cockeyed this way because there was high spots, which there are not any longer. So the last things I had to do when we still had it on the table, with both lifts, was to get the thing squared up. My original measurements were off, and I took it for a test ride, and you could actually see it when you look down from the top that the front wheel was cocked over to the left. So I mentioned, I think in the video 1, that you can tweak these things in situ just like you can if you have a regular set of forks. If you hit something on a bike and the front end's off, you just loosen the mounts and you twist it. And what happens ultimately is the wheel, all right, the wheel is gonna go, it's gonna go that way, but either rotate that way or rotate that way on the axle, depending on which way you go. I had to push the wheel that way, and it went, and it seemed to want to go there. So my original marks were, or my original measurements were off. And right now it tracks really straight, so this is where it's going to stay. And I don't have any reason to take the forks off anymore, these uppers, unless it breaks. I never took the other one down till I did this job. So the thing is, those were in service for about 6 years. So the thing, or maybe 4 years. But anyway, they don't come off regularly. I do have some marks made into them, and made into the lower triple clamp, or the lower fork clamp rather, of the triple tree. And then I have a reference mark. Now, speaking of triple tree, another problem I had with this, and I didn't really notice it, I can't remember if I mentioned in video 1, the steering head bearings were screwed up. There was a notch in the center, and I could tell that when it was jacked up, and with no pressure on the wheel, and you just move the handlebars, you could feel it move away and then notch like it detents into the straight position. So I ordered some new steering head bearings, some all balls, that's what was in there. But when I drove out the bearings, the bearing races rather, the bottom one was a real bitch. I had to make a tool for it. But when I drove them out, the bottom race was like perfect. It was the top race that was damaged. I've never seen that before. So I put new steering head bearings in, preloaded them to where I think was right, because I don't have a socket to torque them up. You're supposed to torque at 10 to 12 foot-pounds to preload them. But I guessed about that, and it seems to be just fine. So we'll go back in there in the future and recheck those, because I want to put some new handlebars on, because these handlebars are all rusty. These Clubman bars, which are coming today, but I'm not going to do it today. But these Clubmans, which are by the way off, I don't know how I got these off toward the right. These Clubmans flipped upside down are what I'm going to use, and I ordered a new bar rather, not set, from Knee Cycle. So they'll come today, and I'll put them on in the near future, because especially on the back side here, you can see it is just really rusted. I didn't notice till I took the handlebars off to do the steering head bearings. I'm sure I'm forgetting something, but there was a lot to this. Going back and forth from the lathe, back to the bike, to the mill, back to the bike, making the spacers, trimming some more off the spacers. The spacers themselves were a job, because I had to cut them off in the bandsaw a little wide. My parting blade is just not that accurate on the lathe. And then put them in with some parallels behind them to line them up into the chuck. Take the parallels out so you don't get one embedded in your brain. And then just face them down to the proper width. Then put them into the soup and get them zinc plated. And like I said, that process worked really well. I was really, really surprised. I ended up powering that with, let's see, a 2 amp, 5 volt, an iPad charger, because it's 2 amp capable, and just butchered up a short USB lead, used some alligator clips to go for positive and negative, and that worked great. I tried a 6 volt, 150 milliamp, 6 volt, 500 milliamp battery charger. Half an amp wasn't enough, especially when there's a bigger part. But when I put that iPad charger on, it worked great. So again, I'll put a link in the description of the website, or the forum rather, Corvette forum I think it was, where I got the information on how to do that. All right, so the next videos are the summary of the machining, and I'm not going to do any blabbering and outro at the end. So at this point, I'll just say thanks for watching. I hope you understand my position on the subsequent videos, unless it's something really interesting, because it's just very difficult to dedicate that kind of time to it. So let's go ahead and get to the machining. Thanks for watching. Don't just repair, restore, and we'll catch you on next video.